Welcome to the tutorial on using Sage. At the end of this tutorial, you will be able to learn the range of things for which Sage can be used, know the functions used for calculus in Sage, learn about graph theory and number theory using Sage. Before beginning this tutorial, we would suggest you to complete the tutorial on getting started with Sage. Let us begin with calculus. We shall be looking at limits, differentiation, integration and Taylor polynomial. We have our Sage notebook running. In case you don't have it running, start using command. So you can type Sage, then you can open the notebook. So to find the limit of functions x star sine 1 by x at x is equal to 0, we say by typing it lim within brackets x star sine within brackets 1 by x, comma x is equal to 0. We get the limit to be 0 as expected. It is also possible to limit at a point from one direction. For example, let us find the limit of 1 by x at x is equal to 0 when approaching from a positive side. Lim within brackets 1 by x, comma x is equal to 0, comma dir is equal to within single quotes right. To find the limit from the negative side, we say lim within brackets 1 by x, comma x is equal to 0, comma dir is equal to within single quotes left. Let us see how to perform differentiation using Sage. We shall find the differential of the expression exp within brackets sine into x square by x w.r.t x. For this, we shall first define the expression and then use the diff function to obtain the differential of expression. That is, you can type var within brackets in single quotes x, then next line f is equal to sine within brackets sine x square by x, and then third line you can type diff within brackets f comma x. Then we can also obtain the partial differentiation of an expression wrt, one of the variables. Let us differentiate the expression exp within brackets sine y minus x square by x, wrt x and y, that is with respect to x and y. So you can type var within brackets in single quotes x space y, then in second line you can type f is equal to exp within brackets sine and again in brackets y minus x square by x, then you can type diff within brackets f comma x, then next line you can type diff within brackets f comma y. Thus we get our partial differential solution. Now let us look at integration. We shall use the expression obtained from the differentiation that we did before, that is diff within brackets f comma y, which gives us the expression e raised to sine minus x square plus y multiplied by cos minus x square plus y by x. The integrate command is used to obtain the integral of an expression or function. So you can type integrate within brackets e raised to sine minus x square plus y multiplied by cos minus x square plus y by x, comma y in the bracket. As we can see, we get back the correct expression. The minus sign being inside or outside the sine function does not change much. Now let us find the value of the integral function, integral between the limit 0 and pi by 2. So for that you can type integral e raised to sine minus x square plus y multiplied by cos minus x square plus y by x, then y, then comma 0 comma pi, that is pi by 2. Then hence we got our solution for definite integration. Now let us see how to obtain the Taylor expansion of an expression using Sage. Let us obtain the Taylor expansion of x plus 1 raised to n up to degree 4 about 0. So for that you can type VAR within brackets x space n in single quotes, then type Taylor within brackets x plus 1 raised to n comma x comma 0 comma 4. We easily got the Taylor expansion using the Taylor function. So this brings us to the end of the features of Sage for calculus that we are looking at. For more, look at the calculus quick reference for Sage Wiki. Next, let us move on to matrix algebra. Let us begin with solving the equation Ax is equal to V, where A is a matrix 1, 2, 3, 4, and V is the vector 1, 2. So to solve the equation Ax is equal to V, we simply say A is equal to matrix 1, 2, 3, 4. Then V is equal to vector 1, 2. Then x is equal to a dot solve underscore right within brackets V. Then you have to type x. To solve an equation x a is equal to V, we simply say x is equal to a dot solve underscore left within brackets V. Then type x. The left and right here denote the position of a relative to x. Now let us look at graph theory in Sage. We shall look at some ways to create graphs and some of the graph families available in Sage. The simplest way to define the arbitrary graph is to use dictionary of lists. We create a simple graph by using the graph function. So G is equal to, you can type G is equal to graph within brackets and in curly braces 0 colon within square brackets 1, 2, 3 comma 2 colon in again square brackets 4 and hit shift enter. To view the visualization of the graph, we say G dot show closing brackets. Similarly, we can obtain a directed graph using the DI graph function. So you have to type G is equal to DI graph, that is D and G are capital, then within brackets in curly braces 0 colon within square brackets 1, 2, 3 comma then 2 colon within square brackets again 4 and hit shift enter. Sage also provides a lot of graph families which can be viewed by typing graph.tab. Let us obtain a complete graph with 5 vertices and then show the graph. So you can type there G is equal to graph dot complete graph within brackets 5. Then type G dot show then closing brackets. Sage provides other functions for number theory and combinatorics. Let us have a glimpse of a few of them. So prime underscore range gives primes in the range 100 to 200. So you can type there prime underscore range within brackets 100 comma 200. So is underscore prime checks if 1999 is a prime number or not. So for that you can type is underscore prime within brackets 1999 and hit shift enter. So you'll get the answer. Factor 2001 gives the factorized form of 2001. So to see that, you can type factor within brackets 2001 and hit shift enter. So you can see the value in the output. So the permutations function gives the permutations of 1, 2, 3, 4. So for that you can type C is equal to permutations within brackets 1, 2, 3, 4, and next you can type C dot list, then closing brackets. And the combinations function gives all the combinations of 1, 2, 3, 4. For that you have to type C is equal to combinations, then in brackets 1, 2, 3, 4, and type C dot list, then closing brackets. So now you can see the solution in the screen. So this brings us to the end of the tutorial. So in this tutorial we have learnt to use functions for calculus like lim function to find the limit of functions, DIF function to find out the differentiation of an expression, then integrate function to integrate over an expression, integral to find out the definite integral of an expression by specifying the limits, then solve function to solve a function relative to its position, then create both a simple graph and a directed graph using the functions graph and digraph respectively, then use functions for number theory, say for example primes underscore range function to find out the prime numbers within the specified range, then factor function to find out the factorized form of the specified number, then permutations functions and combination functions to obtain the required permutation and combination for the given set of values. So here are some self-assessment questions for you to solve. First one, how do you find the limit of the function x by sin x as x tends to 0 from the negative side? Second question, list all the prime numbers between 2009 and 2900. Then third one, solve the system of linear equations x minus 2y plus 3z is equal to 72x is equal to 7, then 2x plus 3y minus z is equal to 5, x plus 2y plus 4 is equal to 4z is equal to 9. So now we can look at the answer. To find out the limit of an expression from the negative side, we add an argument dir is equal to left as lim within brackets x by sin x, comma x is equal to 0, comma dir within double quotes left. And for the second question, the prime numbers from 2009 and 2900 can be obtained as prime underscore range within brackets 2009, 2901. And the third question's answer is, we shall first write the equations in matrix form and then use solve function. So you can type A is equal to matrix 1, minus 2, 3, then 2, 3, minus 1, then 1, 2, 4, then B is equal to vector 7, 5, 9, then X is equal to A dot solve underscore right within brackets B, then type X so that you can view the output of the X. So we hope you have enjoyed this tutorial and found it useful. Thank you.